So this question, out of probably all the questions that are given in this practice problem, practice worksheet, I would say is definitely the longest and the hardest. So if we are to find, actually, let's first do our givens. It is pretty long, so I'll try to do it in this one area right here. Hopefully, I don't have to erase anything. But if we're given a mass of 0.63 kilograms, and we're also given the spring constant, which is 65 newtons per meter, what is, for part A, so this is our givens, for part A, what is the distance that the string is stretched? And so in order to solve that, what I'm going to do is I'm actually first going to make a free body diagram. And if you remember from forces, this is actually pretty important, and it's going to help us sort of understand the problem better. So firstly, we have, so if we have a box or sort of a mass, and it's hanging from this string over here, there are a few forces acting upon it. So firstly would be the force of gravity, right? Sort of pulling it down. However, we also taking into consideration that this box is at rest, so there has to be an equal force that is pulling it upwards. So what is that force? That force is the elastic force. So if we were to make a free body diagram without this big mess over here, it would look something like this. If we're just looking at the y direction, because that's all we really need to look at, we have the force of gravity, and we also have the elastic force acting upwards. And something else we know is that because they are at rest, which I'll write in brackets over here, I already wrote it, but I'll write it again, we know that Fg is equal to Fe because they sort of cancel each other out, meaning that it's in static equilibrium, it's not moving at all. And if we were to find Fg, let's find Fg. So Fg is equal to mg, so mass into gravity. The mass in this case is 0.63 into 9.8. And so if you plug that into your calculator, your force of gravity should be 6.174. And remember, we said over here the force of gravity is also equal to the elastic force. So that means the elastic force is also equal to 6.174 newtons. Obviously, these are acting in opposite directions, so this would be down, and this one would be, up. So now that we got that out of the way, we can sort of solve this question a little bit better. I'll just draw a little divider here to help organize things. Now we need to find the distance that it's being stretched. So if we look back at this diagram over here, we're finding this distance that it's being stretched. What is that distance? Well, we can use the equation elastic force is equal to the spring constant into the distance being stretched. So we're going to plug in everything we know. So we know Fe over here should be solved over here. We got this. So 6.174 equals into K, which is our 65, to the elastic force. And then if we divide both sides by 65, you should get an elastic distance being stretched of 0.09498, but we want to round to two significant digits. So therefore, like so. So this should be your answer for part A. Now, when it comes to part B is talking about the acceleration. And so what it's talking about is if it's not at static equilibrium, so I'll draw another diagram here actually. So part B, if it's not at static equilibrium, and this is the top, and we have a spring over here, and you have this, and you just let it drop. And you let it drop for a distance of 0.41 meters. Sorry, 0.041 meters. What would be the acceleration? And so if we were to sort of update this drawing I just made, so the spring would obviously be 0.041 meters, and we have the box after that. We need to find the acceleration. So how are we going to do that? Well, firstly, what we need to do is we need to remember the equations for the force of gravity, which is mass into gravity, and we also need to remember the elastic force equation, which is this. And something else we need to remember is that in this case, as it's moving down, because there is an acceleration, there is no static equilibrium, which means that one force is greater than another force. So that means the force of gravity would be greater than the force that's keeping it up, obviously, because it's moving downwards, because there's acceleration happening downwards, meaning that gravity is the work that gravity is doing is greater than the work that the elastic force is doing. So what we need to do is we need to find the net force along the y direction, because there's only a y direction, there is no x direction, no horizontal, only vertical. And so to do that, we know that F net y is equal to the mass into the acceleration, like so. And we also know that F net y is equal to Fg plus Fe, like so. How are we going to use this in order to find the acceleration? Well, let's put these together. Let's put these two things together. So I'll write it over here. We have F net y, which is our m a, and then we also have the right side. We have this side over here, which we'll write Fg plus Fe. And something else that is important to remember in a question like this is that when we get rid of these vector arrows on top, we're going to subtract Fe, and that's because we're assuming positive acceleration. But basically what assuming positive acceleration is that the direction that it's moving in, for example, gravity, which acts downwards, that will be positive, and the other will be negative. So like this, ma, and then we could expand these Fg and Fe, so mg minus, like so. I'm going to keep ma on the left side here for now. We'll plug in the mass, which we know, keep acceleration, 0.63 into 9.8 minus 65 into the distance that is falling, which is this 0.041 meters, 0.041. And as we solve, 0.63a is equal to, you should get, so on the right side over here, 6.174 minus 2.665, 3.509, 0.63a. And then we're going to divide 0.63 on both sides. So if we divide, I'm running out of space here. I guess I'll do it over here. So 0.63a, 0.63. We're going to divide 0.63 on both sides to help isolate the a, the acceleration. And so in the end, what you should get is 5.6 meters per second squared. And again, remember it's moving downwards, so the direction would be down. So that is how you find the acceleration for a question like